Today, lesson 11C, angle relationships. We continue with our main theme in this unit of geometric stuff, if you want to think of it that way. Today our focus is on angles and the relationship between angles and, to be more specific, within triangles, also when we have parallel lines, and so on. So today, angle relationships. So right now, I'm going to fly through some background knowledge, a lot of slides where this was all done in the 7th grade. And so there are some blank areas in your notes that you need to fill in, so please make sure that you keep caught up here. So last year, you talked about angles and how to name angles. And an angle is basically defined to be two rays with a common endpoint. In this picture, we have one ray that's AB and another ray that's AC. The corner of an angle, if it's the only corner, we call that point A is the vertex. Every corner is a vertex, but sometimes my point was that we can name this one by its vertex simply because it's the only angle A. And once again, the sides are ray AB and ray AC. And we can call that angle either angle BAC or angle CAB or angle A. And sometimes there's a number at the vertex, like right there's a 5. Sometimes if that's the case, that doesn't mean it's 5 degrees. That just means it's angle number 5. Digging a little deeper into angles last year, that we then transferred over to adjacent angles. And adjacent angles are angles that are next to each other. So in that picture right there, we have angle WXY or angle YXW. We also have angle YXZ, or the flip of that, angle ZXY. And then we also have the big angle in that picture, which is angle WXZ. And once again, this is all from 7th grade. Then after you talked about that, and backing up 1 second here, I mentioned there that we can't name that angle X, and the reason is because if we say angle X, we don't know which angle we're really talking about right there. Okay? So once again, these two angles right here are adjacent to each other. They're next to each other. Then you went to complementary angles. Complementary angles are angles who have a sum of 90 degrees. Sometimes the two angles are adjacent and they make a right angle. But adjacent angles don't have to be, or excuse me, complementary angles don't have to be adjacent. They could be split apart like that. But the key is complementary angles are angles whose sum is 90. Then from there, you went to supplementary angles. Supplementary angles are angles whose sum is 180 degrees. Many times, they're adjacent, like in this picture, to make a straight line. And when they are, we call that a linear pair. But supplementary angles, like complementary, don't necessarily have to be adjacent. They just have to add up to 180 degrees. Then from there, and here's just an example of where we could figure out supplementary angles. This is an actual picture of the Leaning Tower of Pisa, and it is leaning one way, 95.5 degrees. So if we wanted to find out how far it was leaning the other way, that's an example of a linear pair or supplementary angles, and it happens to be 84.5 degrees. And then you went to vertical angles, and vertical angles are formed by intersecting lines. So for example, in this picture, that's an example of a pair of vertical angles. And what we know about vertical angles is that they are congruent to each other. In other words, they are equal in measure. So if that's 37, that angle, the one below it is 37. And on the other side, we have two other vertical angles, two different vertical angles. So if that one is 121, the one opposite it is also 121 degrees. We also have supplementary angles in that picture. Here is a pair of supplementary angles. In other words, that's also a linear pair. Here's another pair right here. Here's another pair right here, or right here. So we've got lots of supplementary angles in that one picture right there. Now we're going to have to put all these things together with new things from this year so we can find missing angles without using a protractor. So once again, vertical angles. In that picture right there, A and C are vertical, and B and D are vertical. And by the way, if you had me last year, I pulled all these slides straight out of lessons from last year. All right, so if I asked you to name all pair of adjacent angles, A and B would be adjacent, B and C would be adjacent, C and D would be adjacent, and A and D would be adjacent. Just lots of terminology there, and I've already talked about the fact that we have some supplementary angles in that picture. All right, do not get these two things mixed up, vertical angles and supplementary angles. Don't get those two ideas mixed up. They're two totally different things. All right, finally, something new. Here in this picture we have a pair of parallel lines. A and B is parallel to CD, and they are intersected by a red line that we typically call a transversal. Now, because of time, I was going to pass out a protractor and have you measure all those angles, but we're a little short on time to do that. What we should see is we should see some patterns within this picture here. And the patterns lead us or come from things like this. So I want you now to just go to the picture right next to it where all the angles are numbered. And so first of all, we're going to see lots of pairs of congruent angles. And the first set will be corresponding angles. So for example, angle 1 and angle 5 are what we refer to as corresponding angles. So angle 1 is congruent to angle 5. Now I have a question for you. What transformation could lead us to that conclusion? A translation. So watch. If I start at angle 1 and translate that down, I have proof that angle 1 is congruent to angle 5 by a translation. So some other pairs of corresponding angles. Well, 2 and 6 are corresponding. Just a translation. That means angle 6 and angle 2 are congruent to each other. Angle 3 and angle 7. Also, angle 4 and angle 8. Those are all corresponding angles. Any questions about corresponding angles? Yes? Are 1 and 4 corresponding? No, they're not. What are they? Anybody know? They're vertical angles. Exactly. That's from 7th grade. That's why I wanted to quickly review all the stuff from 7th grade. All right. Corresponding angles. Next, angles called alternate interior angles. Alternate interior comes from angles that are on the interior or in between two parallel lines. So all of the interior angles are angles 3 and 4 and 5 and 6. But not just interior, alternate. So basically we have angles in between the parallel lines and on alternate sides of the transversal. So what that means is angle 3 and angle 6. So angle 3 is congruent to angle 6. Well, much like my first example of corresponding angles, I have a question for you, and that's this. What transformation could lead us from angle 3 to angle 6 to prove that angle 3 is congruent to angle 6? Rotation. A rotation. So watch, there's angle 3. I rotate it around, and I've just proven to you that angle 3 and angle 6 are congruent to each other. And there's one other pair of alternate interior angles. Could somebody please tell me what they are? Angle 4 and angle 5. Good. And once again, from a rotation. So angle 4 is congruent to angle 5. Well, if there are alternate interior angles, it should make sense to you that there should be also alternate exterior angles. Alternate exterior angles are angles that are on the outside of the parallel line. So we're talking about 1 and 2 and 7 and 8, but on opposite or alternate sides of the transversal. So could somebody give me a pair of alternate exterior? Yes? Angle 1 and angle 8. Very good. So that means angle 1 and angle 8 are congruent to each other. And if I asked you a transformation, well, there we go. A rotation again. And then also the other pair is angle 2 and angle 7. So here's the deal. If we have parallel lines we have lots of angles that end up being congruent to each other because of many reasons. Corresponding angles, alternate interior angles, and alternate exterior angles. But this is only true if we have a pair of parallel lines. And we're going to get into a little more detail on that idea on Friday. But I have one more thing to add that you're going to have to add in that same picture off to the side of your notes. And that would be something referred to as same-side interior angles. The word interior still means the same thing. Angles that are in between two parallel lines. Same-side interior angles, though, are not congruent to each other. And you need to make sure you notate that in your notes. They have a sum of 180. So what we're talking about here is we're talking about like angle 4 and angle 6, and also angle 3 and angle 5. Angle 3 and angle 5 happen to be have a sum of 180. Now, usually at this point, somebody says, well, how do you know that? Well, let me prove it to you. Angle 1 and angle 5, they are congruent to each other. Do you agree with that? Yeah. So, since you know that angle 1 and angle 5 are the same, and angle 1 and angle 3 are supplementary to each other, which means that angle 1 and angle 3 have to add up to 180, it should make sense to you then that angle 3 and 5 also have to add up or have a sum of 180. And so, to prove that point, here we go. I take angle 1, which we already knew by a translation was the same thing as angle 5, and angle 1 and angle 3 are supplementary. Angle 3 and 5 have to be supplementary. And also the other pair of same-side interior would be angle 4 and angle 6. They're not congruent. They have a sum of 180. So don't get that idea mixed up with the alternate interior, alternate exterior, and corresponding angles. Okay. Next part in your notes is this picture right here. I'm telling you that this angle right here is 42 degrees. You need to find all the rest of them. I'm also telling you, I haven't punched it up yet, but angle L and angle M are parallel to each other. And so now lots of things happen because of the fact that you have a pair of parallel lines. Find all the missing angles. And you don't have to write down the reason, but I'm going to ask you the reason why, and then I'm also going to ask you in some of them what translation or what transformation tells us that they're congruent. I'll give you about a minute to a minute and a half to do that. Remember, all of these things are only true because I'm telling you that angle L and angle M are parallel to each other. So here's how this is going to work. I'm going to randomly call people. You get your pick of what angle you want to fill in, but whatever angle you're going to fill in for me, you need to tell me the reason why. Okay? Brandon, you get first choice. Where do you want to start? Angle A. What's angle A? 138. Why? Yeah, good. Good. It's supplementary to the 42-degree angle. Lauren, you get the next one. Your choice.
Angle B.
Angle B?
Yeah.
And what is that?
42 degrees.
Why?
Because it's a vertical angle.
It's a vertical angle to the 42-degree angle. Good. Param, you're next.
I'll do angle C.
Yep.
And it's 138 degrees.
Why is it 138?
Because it's supplementary to the 42.
It's supplementary to the 42. It's also vertical to the other 138. Okay? Trammy, you're next. Angle D is? Why is it 42 degrees? Well, yeah, there's lots of reasons, right? You started to say corresponding. Yeah, that 42 right here is corresponding to that angle right there. But then you also said it's alternate interior to the angle, what was angle B. Both of those are true. Okay? Next, let me get this out of here. George.
I'll take angle E.
Angle E is?
42 degrees because they're alternate exterior.
Alternate exterior. You could also say it's vertical to angle D, right? Okay. Let's go with Autumn.
Angle F is 138 degrees.
Why?
Because it is supplementary to angle E, which is 42 degrees.
Yeah, and there's lots of reasons, right? You can use alternate exterior, you could use corresponding, lots of reasons. And obviously, angle G is 138 because it's vertical to the other 138. All right, any questions with number 1? Should be pretty easy. All right, let's continue on here as I bring up all of these that we just went through. A couple of other things, and then we're going to try some pictures that are a little more difficult. A real-life example of where all this angle stuff comes in. I'm sure everybody in here at one point in your life has either played air hockey or pool. And if you have, you notice that there are dots on all the sides. Well, there's reasons why there are dots on the sides. And watching enough people play air hockey, most people realize it in air hockey, but they don't use the same strategy in pool. But those dots are there for a reason, and it's because everything is mapped out to help lead you to either a goal in air hockey or to sink the ball into one of the pockets in pool. All right, continuing on, the triangle sum theorem, and this was something also from 7th grade. If you add up all 3 angles in any triangle, they will always add up to 180 degrees. So if I asked you to find that angle right there, I'm not going to ask you because it's too easy. That missing angle is 30 degrees. And there are several ways of getting there. Now, proof that the triangle, or why all 3 angles in a triangle add up to 180. There are several proofs I want to show you really quickly. Here's one. I'm going to start with that triangle. Now I'm going to draw lines through all of the sides of that triangle. And then up at the top, I'm going to draw a red line that's parallel to the bottom blue line, like this. And if I used what I just talked about, the idea of parallel lines and also some angles that we just talked about, watch. All 3 of those have to add up to 180. Do we agree with that? Angle P, angle B, and angle Q? Yes or no? Yeah, because they're on a straight line right there. But not only that, I also should realize that angle P and angle A are congruent to each other. Why are they congruent to each other? What kind of angles are they? They're alternate interior angles. And also, we should realize for the same reason that angle Q and angle C are congruent to each other because of alternate interior angles. So if I now substitute, since I just told you that angle P and angle A are congruent to each other, and the same thing with Q and C. So if I substitute angle A for P and angle C for Q, I clearly show you that angle A plus angle B plus angle C is equal to 180 degrees. Or I could prove it to you by what I call an elementary proof of that. And that would look something like this. If I take my triangle and I cut off angle B and put it next to angle A, and then if I cut off angle C and move it over there next to angle B, I have basically a supplementary situation there. Angle B and angle C and angle A clearly have to add up to 180. So that's just kind of an elementary proof of that. All right, so I'm going to throw in a couple more pieces of information. Next would be an exterior angle. So if I have this picture right here, the blue question mark, that's referred to as the exterior angle. All of those other angles inside the triangle, those are interior angles because they're inside the triangle. Anybody know how we could find that blue exterior angle in my original picture there?
You could, since the line, the ray,
Yeah.
I would say, is 180 degrees, you could subtract the interior angle to get the exterior.
Okay, you could do that. One other thing I want you to see here, and that's basically what I'm showing you right there, is that those two angles, the question mark and the 53, have to add up to 180 because they're supplementary to each other. But one other thing I'm going to show you is this. That if we utilize that strategy that I just talked about showing you the elementary proof of 3 angles in a triangle add up to 180, you should realize something, and that's the fact that angle B and angle C make up that exterior angle. Look, that angle and that angle. That's what I'm showing you right here. So another way of looking at it is you could find the sum of the two interior angles that are opposite that, and it would be the same thing. So if I add those two up, I would get 127 degrees, or you could do the supplementary situation there. So several ways of getting that exterior angle. All right, I'm going to add one other thing here, and it's probably something that all of you realized, that if you add up angles inside any quadrilateral, they will always add up to 360 degrees. And I'm giving you all these pieces of information because we're about to apply all of them in one picture. And proof of that is this. If I take a triangle, which now this is about the fourth or fifth time we've seen this triangle, and I put another one right next to it, each triangle, the sum of the angles is 180 degrees. So if I put them together, I now have 360 degrees. So any four-sided polygon, any quadrilateral, when you add up the interior angles, they add up to 360 degrees. All right, let's take a look now at number 2. Work with your shoulder partner to fill in all of those missing angles and talk about the reasons as you're going through them. I'll give you about 3 minutes. So when I look at this picture, I see a couple of pairs of parallel lines. I see a triangle in there. Everybody see the triangle? I also see a quadrilateral in there. Everybody see the quadrilateral? It happens to be a parallelogram, but so all of those things that we just talked about, which a lot of it was review from 7th grade, but I've added some new pieces, the corresponding angles, alternate interior, alternate exterior, same side interior. So when you put those together with the things from 7th grade, vertical angles, supplementary angles, the triangle sum theorem, using all those things, you should be able to easily find all of the missing angles in that picture. Could somebody help me out here? Where do we want to start? Yeah. Okay, but how do you know angle 1 is 113 without anything else? First of all, when I look at angle 1, that's an acute angle. That's not an obtuse angle. 113 degrees is bigger than 90, so it can't be 113. Where should we start? Yes.
Angle 6 is 113 degrees.
Yes, it's 113 because of vertical angles. This is 113 degrees. Where should we go from there? Yes.
Angle 8 is 67 degrees.
Yeah, because of supplementary angles. So is angle 7. Where should we go from there? Yeah.
Angle 3 is 71 degrees.
Because of vertical angles. Where should we go from there? Yes.
Angle 9 is 42 degrees.
How do you know that?
Because in the triangle it has to equal 180 degrees.
Very good. Where should we go from there? What's next? Yeah.
Angle 12
Is
42 degrees.
vertical angles. Where should we go there? Or after that? Yes.
Angle 11 is 138 degrees.
Because of supplementary angles. And angle 10 is also 138 because of vertical angles. What else? Yes.
Number 2, angle 2 is 67 degrees.
Because
Alternate interior.
alternate interior. Good. I'm going to go ahead and fill in angle 5. It's 67 also because of vertical angles. Now what?
Angle 1 and angle 4 are 42.
Are there what?
42 degrees.
Lots of reasons. You got some angles on a straight line there. It's also alternate interior to angle 9. And then angle 1 will be the same because it's vertical to angle 4. Now, where do we go? Yes?
Angle 17 is 42 degrees.
42 degrees. How do you know? Alternate interior? Also, I look at it as the same side interior. Angle 10 and angle 17 are same side interior. They have to add to 180. Where do we go from there? Yes?
Angle 20 is 42 degrees.
Okay, what else? Come on, the hard part's done. Yeah.
Angle 18 is 138.
Yeah, because of supplementary or from corresponding with angle 10 Angle 19 is also 138 because it's vertical. Come on, we've got 4 left.
Angle 15 is 138
How do you know?
because of alternate extreme.
Yeah, or it's corresponding to angle 18. The hard part is done. Angle 14 is 138 because of vertical. 13 is 42 because of lots of reasons. And 16 is 42 also because of many, many reasons. So any questions about that picture? All right, here's what I want you to do. I'm going to leave that up there for about another minute. I want you to get as much of number 3 done as you can before you leave. Number 3 is actually easier than this one. And I may have to end up going through number 3 tomorrow after the test. But go ahead and get as much of it done now before the end of the period. Easy place to start would be angle 6, since it is vertical to the 39-degree angle. And then we can use ideas of supplementary angles or a linear pair. So we have 141 degrees here, 141 degrees here, because angle 1 and angle 5 are vertical to each other. From here, let me erase that. Angle 4 and angle 6 are corresponding angles. So angle 4 is 39 degrees. Angle 3 is vertical to that, so it is also 39 degrees. And then if we take a look at angle 4, angle 10, and 72 degrees, or angle 10 and 72 degrees and angle 3, those 3 together sit on the straight line. Therefore, the 3 of them have a sum of 180 degrees. 72 and 39 is 111 degrees, so that makes this one 69 degrees. Now we can work within our triangle here. 39 and 69 is 108. That means angle 11 is 72 degrees. Obviously, angle 2 is also 72 because it's vertical to angle 11. And then 12 and 2 are supplementary, so angle 12 is 108 degrees. And angle 9 is vertical to that, so therefore it is 108 degrees. And that should, oops, we still have angle 7 and angle 8. Angle 7 is obviously vertical to angle 10, and angle 8 is vertical to the 72-degree angle. And now the picture is complete. As long as we have parallel lines, we have lots of special things that happen. We can look for things like corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. And then we need to look for things like if we see triangles within our picture, using the triangle sum rule. If we have quadrilaterals within our picture, we can use the fact that all 4 angles in any triangle, or excuse me, inside of any quadrilateral have a sum of 360 degrees. And that is it for today.